In this video, we will learn about the orbital speed of a satellite, energy of a satellite, time period of a satellite. Orbital speed, a minimum velocity required by a satellite, be natural or artificial, to revolve around the planet of mass m and radius r. If the radius of orbit is r and h be the height of the orbit above the surface of the earth. Since the satellite is revolving, the gravitational force will in turn produce a centripetal force. Thus, the orbit speed of the satellite would be Vo is equal to square root of gm upon r. Vo is equal to square root of small g capital R, where h is very small than r. Inputting the values of small g and capital R in the above relation, the orbital speed of the earth comes out to be 7.92 km per second. Mr. Atul Malhotra of Puran Chandra Vidya Niketan, Kanpur will tell us more about this topic.
In this topic, we will study about the orbital speed. The question is, what does it means? It means a minimum velocity required by a satellite, may be natural or artificial, to revolve around a planet of mass m and the radius r. And let us say the radius of orbit is small r, which is given as capital R plus h, where h is the height of satellite above the surface of earth. Let the mass of satellite be m. Since the satellite is revolving in a circular path, it means a gravitational force will provide the centripetal force for the motion, that is F is equal to capital G capital M into small m upon r square, and the F is equal to mv square upon r. On equating these two forces, we will get the result mv square upon r is equal to capital G capital M into small m upon r square. Now, we get the result V is equal to under root gm upon r. This speed is known as orbital speed, that is the Vo. Now, we can also write this formula, that is Vo is equal to gm upon r. Put gm is equal to small g into r square and r is equal to capital R plus h. So, we will get the result Vo is equal to under root g r square upon r plus h. This is another result. If the value of h is very less than compared to the radius of earth, then we can get Vo is equal to under root g r square upon r. Cancel these terms, Vo is equal to under root gr. If we calculate the value of orbital speed for a nearby satellite for earth, then we put the value of, that is g is equal to 9.8 and the radius of earth is 6.4 10 की power 6 meter. On solving it, we will get the answer 7.92 kilometer per second. In this topic, we will study the energy of a satellite. As we know that whenever a satellite revolves around the earth or a planet, it contains two types of energy. One, that is the kinetic energy due to its motion, and another is the potential energy due to its height above the earth's surface. First, we calculate the kinetic energy. The general formula of kinetic energy is half mv square. We can write it as Vo for orbital speed. That is, kinetic energy is equal to half m. Put the value of Vo, that is capital Gm upon r raised to the power whole square. Kinetic energy is equal to half. On solving it, we will get capital M into small m upon r. In the last topic, we have studied about the potential energy, that is minus capital G, capital M into small m upon r. To obtain the total energy, we will write it as half capital G, capital M, small m upon r plus in the bracket minus G, capital M upon r. On solving it, we will get the result total energy is equal to minus half G, capital M into small m upon r. We will discuss about the time period of a satellite revolving around the planet or earth. Suppose there is a planet of mass m and the radius r. From the center of the planet at a distance r, a satellite is revolving around the planet in the circular orbit, where the small r is given as capital R plus h, where capital R is the radius of earth or planet. Now, to calculate the time period, we will use the formula total distance covers, that is 2 pi r, and its speed, that is VO, is equal to 2 pi. In the place of r, we will write capital R plus h. In the place of VO, we will write it as G r square upon r plus h. On solving it, we will get the expression 2 pi in the bracket r plus h raised to the power 3 by 2 upon under root g r square. For a nearby satellite, it means when the h is very less than r, we can write it as t is equal to 2 pi and r की power 3 by 2 upon under root g r square. On solving it, we will get it 2 pi under root r upon g. For nearby satellite, we will put the value of r and g, that is 6.4 10 की power 6 upon the value of g is 9. The result will give approximate 84 minutes.
Energy of a satellite. Whenever a satellite revolves around the earth or a planet, it contains two types of energy. One is the kinetic energy due to its motion, and the second is the potential energy contained in it. That is, total energy is equal to kinetic energy plus potential energy, that is equal to minus 1 upon 2 into Gmm upon r. Time period of a satellite. The time required by a satellite to make one revolution. That is, t is equal to 2 pi r plus h raised to 3 by 2 upon root of gr. For a nearby satellite, that is when h is very small than r, t is equal to 2 pi into square root of r upon g, which is almost equal to 84 minutes.
For more such videos, log on to CBSE section of jagranjosh.com.